Hello, I'm Fiona McGill, founder of Soma Noēsis. Soma Noēsis is a novel structural intelligence technology enabled by a new mathematical innovation. As renewable generation, battery storage and distributed energy resources continue to expand, energy systems are becoming increasingly complex. Existing monitoring systems generate enormous amounts of operational data, but understanding how the underlying structure of a system is changing remains a significant challenge. Soma Noēsis provides an additional analytical layer by analysing the structural organisation of complex systems. Rather than replacing existing models or forecasting tools, it complements them by providing structural insight that can support grid monitoring, engineering decision making, and structural diagnostics and AI validation. Of course, a new idea is only valuable if it can be demonstrated in practice. To evaluate Soma Noēsis, I've benchmarked it across multiple energy systems. The primary validation used a renewable rich Nordic energy benchmark, where Soma Noēsis consistently distinguished different operating regimes and matched the fastest detection time whilst avoiding a coherent regime false positive. I then applied the same approach to UK grid operational data, where Soma Noēsis distinguished the August 2019 major grid disturbance and identified an additional structurally distinct event for further investigation. A voltage disturbance benchmark further demonstrated structural discrimination beyond signal magnitude alone. Beyond energy, Soma Noēsis has also been benchmarked across chemistry, optics, quantum systems, oscillatory systems and artificial intelligence. The research has been presented internationally at the International Symposium for the Philosophy of Chemistry, and the technology is currently at technology readiness level 3 to 4. These benchmarks have allowed me to validate the analytical capability of Soma Noēsis and develop a partially functioning software prototype in Python. Today, the prototype analyses historical operational datasets, identifies structural operating regimes and produces engineering outputs. The next stage is to evolve this analytical prototype into an operational platform capable of analysing live data streams from existing infrastructure such as SCADA systems, PMUs and other operational monitoring tools. The goal is not to replace existing monitoring systems, but to provide an additional structural intelligence layer through a decision support dashboard, helping engineers understand how increasingly complex energy systems are evolving. I've led every stage of the development of Soma Noēsis, from the underlying mathematical innovation through to the analytical prototype and benchmark program. The technology has now been validated across multiple scientific domains and presented internationally at the International Symposium for the Philosophy of Chemistry. The next stage is building the partnerships needed for industrial deployment. Through TechX, I'm looking to work with energy companies, software engineers, energy systems specialists and academic researchers to develop the operational platform, undertake industrial pilot projects and accelerate commercialisation. The ambition is to establish structural intelligence as complementary analytical technology, supporting increasingly complex, resilient and low-carbon energy systems. Soma Noēsis has now reached a stage where the underlying technology has been demonstrated and the focus is now on translating that capability into an industrial product. TechX would provide the support needed to accelerate that journey by helping us further develop the prototype, validate it with industrial datasets and prepare it for deployment. Scotland is leading the transition towards offshore wind energy storage and smarter electricity networks. As these systems become increasingly complex, Soma Noēsis has the potential to provide an additional structural intelligence layer that complements existing monitoring and supports engineering decision making. Our long-term ambition is to establish structural intelligence as a complementary technology for resilient low-carbon energy systems across Scotland, the UK and international markets. We believe the future of energy won't just need more data, it will need better ways of understanding its structure. Thank you for considering our application.